in examples 3 and 4, which we're going to look at now, we are going to do very similar things to example 1 and 2. We are going to create tables, and we are going to graph quadratic functions. The difference is we are going to use the graphs that we create to answer questions. Now, the question in example 3 has to do with a race car. And we want to know the distance that this race car will travel within a certain time period. And the last sentence of the problem says we are to use the graph to find how much time it will take for the race car to travel 200 feet. So once again, I've left the graph on the screen. That is our goal. That's what we're going to get to. But if we had to build that from scratch, what would we do? Well, we would still need to come up with coordinate pairs that we can put on the grid and then be able to draw our line. And then once we have our line, do the interpreting. So let's go through this process again very briefly. Let's try and break it down. Remember, what are the steps that we have to do? We're going to make a table. Then we've got to come up with x values. After we come up with x values, we're going to substitute those into the equation. Once we substitute, we solve. Once we solve, we have our y values. Once we have our y values, we have our coordinate pairs. Once we have our pairs, we plot the points. And then after we plot the points, we can draw a line. So that is the process we are working at. So the one thing that is different about this scenario is that it's a real-world scenario. We're talking about time and distance, and in the real world, time and distance usually are not negative. So we are just going to use positive values. So let's plot about 5 points. So I'm going to use 0, 1, 2, 3, and 4. And once again, I'm going to take the 0 that it came up, I'm going to substitute that into the equation. So I'm going to take 0, and I'm going to put it in place of, in this case, it's t. So I'm going to substitute that in for t, and I end up with 4 times 0 squared. Okay, well, 0 squared, or 0 times 0 is 0, and 0 then times 4 would also be 0. So when I put 0 in to the equation, I get 0 out. Okay? And then when I combine the 0 for the x or t value and then the other 0 that we get out, my coordinate pair is 0, 0. And I'm going to go ahead, and as you can see, we're going to plot that point right here. Now I'm going to continue to work quickly through the rest of the table. All right, so here I'm going to have 1 squared times 4, and that's going to be 1 times 4, which is 4, which is going to give me a coordinate pair of 1, 4. Plot that point on the graph. Then if I use 2, I have 4 times 2 squared, all right, which is 2 times 2, which is 4 times 4 is 16. So I have the point 2, 16. Let me go ahead and plot that one right here. All right, carrying on in the same fashion, I have 4 times 3 squared. 3 squared is 9. And 9, times 4 is 36. So now I have the point 3, 36. And I'm going to go ahead and plot that. And then lastly, we're going to look at 4. And I have 4 times 4 squared. 4 squared is 16. 16 times 4 is going to equal 64. And so my last coordinate pair that I'm coming up with for this example is the point 4, 64, and I plot that. Now, as you can see, we can carry on doing a couple more points, which would be good because it helps us do a really good job of a curve. But once I've plotted those points, now I can do the last thing, which is draw a line that connects most of those points, all right? And like I said, the difference now in example 3 and 4 is we've got to answer a question. Let's go back to what the original question was. The question was, how much time will it take for the race car to travel 200 feet? So using my graph, I want to know, well, where is 200 feet represented on the graph? Well, 200 feet is represented by distance, and we can see distance here is on the y-axis, okay? So let me find where 200 would be on the y-axis. See, so it looks like 200 would be right here. Now, in order to find out what the corresponding time value is for 200 feet, I'm going to travel across, as you can see this red line does. I'm going to travel across to the line I created right here. And then from that point, I'm going to travel straight down to the x-axis, to that point. And I would say it looks like somewhere between 6 and 7 seconds. If we're being very specific, we could say 6.7 seconds is the time it takes to go 200 feet. If we're being approximate, maybe more like 7 seconds. So let's break this down again. We created a table, came up with x values right here. We substituted those x values in right here. We solved each and every single one of the equations, came up with coordinate pairs. When we had the coordinate pairs, we plotted them in the equation. Then we drew the line, and then we used our graph to answer the question that they had. The next example is very similar. I'm going to leave the table already done, but I assure you they did the same thing. They created the table. They came up with these x values. In this case, they used the variable d. It doesn't matter. It's still the independent variable. And they substituted their variables into equation. They solved and got 0. They used the independent variable and dependent variable to create their ordered pair. They plotted their ordered pairs and did that several times, and then came up with the equation that you see here. Now, this problem has to do with hot air balloons, okay? So when we're traveling in a hot air balloon, we can see a very far distance. And of course, the farther you can see farther, the higher you are. So they want to know, well, how far can you see if you're 1,000 feet in the air? So height is on the y-axis. So once again, we're going to find 1,000 feet on the y-axis. Once we found that, we're going to travel completely horizontal over to our line that we created. And then we're going to go straight down to the x-axis. And what you can see is the point almost 40 miles, maybe 39 miles would be more accurate. So when a hot air balloon is 1,000 feet in the air, you are able to see a distance of 30 miles. So once again, we're doing all this work in order to create a graph that we are going to use to answer a specific question. The got it problem is very similar. Read the problem about the Seattle Space Needle and answer that question, pretty please.